So our lesson today is section 2.4, which is all about solving inequalities. So far in this class, we've been working on solving equations, and equations are math sentences, and inequalities are as well. So like this math sentence right here, where you have these two expressions and an equal sign between it, that's an equation. So is this one, but these two are inequalities because instead of equal signs, they have a relationship of being less than or greater than or equal to. So if you ever have a hard time knowing like which one is which and like which direction it should go, the smaller number should always go on the smaller side of the arrow and the bigger number should always go on the bigger side of the arrow. And if there's this bar underneath it, that means that it's okay for the two things to be equal. So it would be a true statement to say like 2 is greater than or equal to 2 because 2 is equal to 2. But it would be a false statement to say 2 is greater than 2 because that's not true. Does that make sense? Okay. So if we look at this inequality and we wanted to find a solution for it, remember a solution is something you can put into the variable to make the statement true. So what would be a number I could put into this inequality that would make it true? Yeah. -2. Okay, so have x equal 2 because if you plug that in, you'd have the opposite of 2 is less than 2, which is a true statement. So I'm going to graph that on my number line with a point. So x equals 2 is a solution. Are there any other solutions? And sorry, say that again. All the negative numbers. Okay, so like I'll do 1, 0, -1, -2, -3, -4. So you're saying like if I had x equals -4, I could plug that in. So if I had -4 less than 2, well, the opposite of -4 is 4. Okay, so maybe I'll do an X on that. So we know that's not a solution because 4 is not less than 2. Okay, so that's not a solution. What would be something that would be a solution? 4. Okay, yep, that one would work because in that case we'd be doing, I'm going to run out of room here, but we'd have the opposite of 4 is less than 2, which is true. So 4 would be a solution. Any other possible solutions? So we know that 2 and 4 are solutions. What about the numbers in between 2 and 4? Are those solutions as well? So like a 3, if we plugged a 3 in, we'd have the opposite of 3 is -3. -3 is less than 2. So that one would work. And basically anything like 2.5, 2.7, any number in there would work. What about numbers bigger than 4? Would those work? Yeah, because like even if I plug in like 100, which is like way far up the number line, if I do the opposite of 100, that's -100 is less than 2. That's true. Because pretty much any negative number, regardless of like how big that negative number is, it will be less than a positive number. So all of those numbers will be solutions. Is there anything in this part that would not, or that would be a solution? Yeah. -1. Okay, so we could try that out. If x equals -1, we would get the opposite of -1 is less than 2, which we could write as 1 is less than 2, which is true. So that's a solution. And I think everything in between there would also be a solution, right? Because like all of these numbers will turn into negatives when you do the opposite of them. And then these numbers are going to be like the opposite of like -0.5 would be 0.5, but 0.5 is still less than 2. So all of those are going to be solutions. Are there any other solutions? So we can maybe go to the next smallest whole number. If I plug it, will that make a true statement? No. What if I do something in between -2 and -1 though? Yeah, like even if I did like -1.99999, that would still work because the opposite of -1.999 would be 1.999, and that's still less than 2. So whenever we have this situation where like you can get really, really close to the number and get a solution, but the number itself is not a solution, we represent that with an open dot. So an open dot means that you can get infinitely close to the number, but the number itself isn't a solution. Because if I put in a -2, the opposite of -2 is 2, and 2 is not less than 2. If it were an equal to sign underneath here, then it would be a solution and we do a solid dot there. But because it's just less than, then that means it's not a solution. So this dot right here ends up being the boundary between the solutions and the non-solutions, because anything on this part is going to not be a solution. You know, like -3, if I do the opposite of -3, that's going to be +3, and +3 is not less than 2. So everything on that part is going to be a non-solution, and everything from here upwards is going to be a solution. And notice that the boundary point happens if this like the point where it's going to have a boundary is if you solve the equation -x equals 2. Because if you solve that equation, you divide by a negative and get x equals -2. And that makes sense that like an equal sign is like the boundary between solutions and non-solutions, because having two things be equal is kind of like, I don't know, it's like the tipping point between being greater than or less than. You know, so like at one point, like, I don't know if I'm explaining that very well.
I was just remembering, I'm like, well, a trick I remembered is if it's pointing this way, it goes this way, pointing this way, then it goes this way.
Mhm.
And I'm like, if we changed it to just divided it, so it'd be -2, the thing switches, so.
Mhm. Yep. So what you just shared is actually the point I wanted to make with this slide. So thank you for that. Because we can solve inequalities for x. So like in this case, x was not by itself. And so I'm like running out of room here, but if I had -x is less than 2, we can solve this inequality just like you would solve an equation by dividing by -1, which gives you x and -2. However, in inequalities, if you ever divide or multiply by a negative, because of the way that the solutions work out when you multiply something by a negative like this, you have to switch the direction of the inequality. So solving inequalities, which is what our whole lesson is about today, it works basically exactly the same as solving equations. The only thing that's kind of like an added on thing is that if you divide or multiply by a negative, then you have to switch the direction of the inequality. And you can kind of see like why that works here, because the solutions to this inequality were all of the numbers that were greater than -2. And like if we had left the inequality going the other way, then it wouldn't like actually give us solutions. Yeah.
That only happens with negatives, right? Small numbers.
Yeah, so it's only multiplying or dividing by negatives. And you can even add and subtract negatives, that's totally fine. It's only multiplying or dividing. To show an example of like adding and subtracting negatives. So like, let's say I had x plus 1 is less than 5. If I wanted to show all of the places where this is true, I would say, well, at 3, it's true, right? Because 3 plus 1 is less than 5. 2 plus 1 is less than 5. Like basically I'd have all of these numbers and also negative ones as well. Like if you plugged in like a -7, -7 plus 1 would be -6, which is less than 5. And then our boundary point would be at +4. And I'd have an open circle there because if I plug in a 4 plus 1 is not less than 5. But if I plug in a number that's just a teeny bit smaller than 4, like 3.99999, then it does work. So in this case, we can kind of see just by what we know about solutions that it has to make it true that our solution set should be x is less than 4. And you can see if we were to solve this by subtracting 1 from both sides, when we do that subtraction of 1, the sign doesn't change. It still stays the same direction as the original inequality. So the only time it changes is if you multiply or divide by a negative. Adding and subtracting negatives is totally fine. And it's also only if you multiply or divide both sides of the inequality by a negative. So like, let me find an example. So like on this one, where you multiply -2 by this side, this would not be a case where you would flip the sign until you divide it by -6, because you have to do it on both sides. Doing -2 times these two to distribute is just simplifying one side of the expression. So let's see. Okay, so if we wanted to solve something like this one is a little bit harder to just do in our head and figure out. I'm gonna resize this slightly so you guys can see it a little better. Can you see the bottom of the number line fine? I think that's far enough. Okay, so on this one, we're going to basically go through and solve the inequality just like we'd solve an equation. So I'd subtract 5 from both sides, which would give me -3x is greater than 6. And then I divide both sides by -3. And because I'm dividing by a negative, it's whenever you multiply or divide by a negative, then I need to switch the inequality so it goes the other direction. And so my solutions, if I wanted to draw it on a number line, I'd have an open circle at -2. And then it's all of the points that are less than -2. Oh, that's worse. Sorry. Okay. All right. So do you guys have any questions on that? On like how the graphing works? And again, if this was a greater than or equal to, then this would be a solid circle. So you only use open circles when the number itself is not a solution. All right, so when you, on your homework, there's 3 different ways they're going to ask you to report the solutions to an inequality. So let's say you had some inequality and once you solved it all the way down, you ended up with this solution. So you know that it's all of the numbers that are greater than or equal to 4. There's 3 different ways that you may be asked to show this solution on your homework. One of them is the one we've been using so far, which is a number line. So if I wanted to show this on a number line, I would do a solid circle at 4. And the reason it's a solid circle is because if I plug a 4 in, it makes a true statement. So I would have a solid circle at 4, and then it would be all of the points that are bigger than 4. So that's how I would show the solution on a number line. Interval notation is basically just a typed out way to represent this same concept. So interval notation, you have 2 different spots, one of which is the lower bound of your solutions and one of which is the upper bound. So if we look at this solution set, the lower bound is a 4. So that's going to be our first number. And then the upper bound, there actually is no upper bound, right? It like goes on forever and any number that's bigger than 4 would work. Yep. And so in that case, we do positive infinity as our upper bound. And then we're going to put brackets or braces around these numbers, depending on whether or not these numbers themselves can be solutions. So the number 4, if I plug that in, that is a solution to the inequality. So I'm going to put a square bracket around it. If it had just been greater than, then you would do a round bracket. So round brackets are kind of like open circles on the number line. Square brackets are like closed circles. And then the number infinity actually isn't a number. The infinity is like the idea of something going on forever. And so since this isn't a number, you can't plug it in and say, oh, infinity is greater than or equal to 2 because like infinity isn't even a number. And so infinities will always have round brackets because you can plug in an infinitely big number, but you can't plug infinity itself into the inequality. So that's what interval notation looks like. And then set builder notation. So really quickly, a set is basically a list of a whole bunch of things. So usually it's numbers, but we could also have like a set that represents all the people in our class, and we could list out everybody that's in our class. With numbers, you might have like the set of even numbers, which you could write like this. And you probably want to do like a dot, 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 because you don't want to literally write out all of the possible even numbers. But with set builder notation, you don't want, like, if you think about listing out all of those numbers, there's not really a way that we could list those, right? Because it's like, it's 4 and it's 5 and 6 and 7, but it's also 4.1, 4.2, 4.0012. Like, there's way too many numbers and like we can't really show the pattern. So what we do instead is we do a set builder notation where we say we want it to have all numbers X such that X is greater than or equal to 4. So the thing that goes here is a variable that describes what what things go in the set. And then after this vertical bar, you describe what these things have to meet in order to be in the set. So you could also do set builder notation for the people in our class. And you could say it's the set of all P such that P is a person in our class. Does that make sense? So it's like whenever you have something that can't be listed, like the even numbers, then you can build a set by saying it's all of these things as long as those things meet this requirement. So that's set builder notation. So let's do a quick check-in on a scale of 1 to 5. How do you guys feel about all the stuff we've learned so far? Okay, awesome. Do you guys have any questions or any clarifications? All right. Okay, so to summarize the different ways that you might express the answer, we have interval notation where you use round brackets if the symbol is less than, greater than, or if the bound of your solutions is infinity, you'll use round brackets. If the symbol is less than or equal to or greater than or equal to, then the number itself will be able to be a solution, and so you'll use square brackets. Similarly, if you're doing it on a number line, you have open circles if the number itself is not a solution, closed circles if the number itself is a solution. And that number is like the boundary point that you solve for. And then set builder notation, you have the variable, and then you have the condition that the variable needs to meet in order to be in the set. So let's see. So on your homework, you have most of the problems, they'll give you an inequality and you have to find the solutions. But on some of them, you'll be given a set of solutions and you have to write the inequality. So in this case, what would be the inequality that this number line represents?
Circle bracket with infinity, comma, 5, another circle bracket.
Perfect. So it would actually be negative infinity because it comes from the negative side. Yep, so this would be another way of expressing these solutions. But what are these solutions a solution for? Like, what's the inequality that they're a solution for? Yeah. Perfect. Yep. So on this one, the inequality that these two solution sets, which are just different ways of saying the same thing, the thing that they're solutions for is the inequality x is less than 5. And the reason we know it's less than and not less than or equal to is because this was an open circle. If it was a closed circle, then you would do less than or equal to. So you'll have a couple problems like that. And then most of the problems are not this complicated, but these are some of the later ones. But the process for solving inequalities is basically the same as solving equations. So like, for example, if you have this one where you have fractions, you would just multiply both sides of the inequality by 15 to get rid of the fractions, and then you'd solve it from there. On this one, you would distribute the -2 to get rid of the parentheses, and then you'd solve it from there. Yeah.
Okay, so when you move the sign, it's just when you're dividing by the x, right?
So you flip the sign if you multiply or divide both sides by a negative.
Okay, by anything, like including the fraction to get rid of the fraction, you multiply it by the circle to get the other side. Does that make sense? I think it's just if you divide by the x, if it's a negative x.
So it's anytime you multiply or divide by a negative. And so it's like, if it's a negative number and you multiply or divide both sides by it, then you flip the direction. So like in this case, I would make this one simpler by multiplying both sides by 15, but 15 is not a negative. And so it wouldn't flip it. On this one, I would start off by getting rid of my parentheses and I'd say like negative 2 times 3x is negative 6x, negative 2 times 5 is 10, or negative 10. But that is just simplifying one side of the inequality. It's not doing it to both sides. So I wouldn't flip it at that step. But eventually I would need to get rid of the negative 6x to get x by itself. And so when I divided it by negative 6, then I would flip it at that point. Does that answer your question or? Okay. And then on this one, you would, again, just kind of simplify it the same way. So you get rid of the parentheses in both of these parts. And then since you have a whole bunch of x's, you would combine like terms, and you would also, since you have x's on this side and x's on that side, you'd have to subtract or add x's, get rid of one of them. So I'll go through some more examples like that. But the basic idea, to summarize, is that inequalities are solved just like equations, except if you multiply or divide both sides of the inequality by a negative, you flip the sign. And then you have these 3 different ways of representing your solutions. So those are the key ideas you need to be able to complete your homework. You also have one word problem on your homework. And I want to just kind of go through an example of kind of how you interpret word problems for inequalities. So on this one, remembering whenever we do word problems, we want to look for things that we know and things that we need, and then use the things we know to find the ones that we need. So on this one, it says the pay for a mathematics major graduating from college is given by this formula, where T represents the years worked after college. And they didn't actually tell us what P represents. So they told us this T is the number of years, but we don't know what P is. But we can kind of tell from the way they phrase the sentence that it's the pay for a mathematics major, which makes sense because pay starts with P, because they said that the pay for a mathematics major is given by this formula. And so that's how we know that this P right here represents the pay for a mathematics major. And then it says how many years, so this is what we're looking for, would a mathematics major expect to work to be earning at least $100,000 per year. So if we look at this equation, what it basically means is like if you haven't worked any years, so if T is 0, then your pay is going to be $48,000. And then for every year that you work, so like let's say you work 1 year, you're going to make $2,650 more than that. So essentially, this is your starting pay. This is how much of a raise you get every year. That's essentially what that equation is saying. So we're looking for how many years would you have to work in order to be earning at least $100,000 per year. So the key word here is at least, because what we're looking for is when is the pay going to be greater than or equal to 100,000, right? Because that's like, if you want to be earning at least 100,000, your pay needs to be bigger than or equal to 100,000. And so to solve it, you would just say, well, I know that my pay equals this amount. So you'd put in 48,000 plus 2650T is greater than or equal to 100,000. And then you'd go through and solve that, figure out what T is, and that would be the number of years that you would need to work in order for your pay to be over 100,000. So that's kind of how you break down a word problem. And I'll let you guys figure out this one, but if you have questions, you're welcome to ask me about it. So that's it for the, I guess, like instruction part at the beginning. So if you guys want to pull your computers out and start working on your homework, you're welcome to. And I'll just go ahead and start solving some of the problems on the homework that I thought were more challenging. And if you want to, you can follow along, do the problems with me, or if you want to solve the same problem on your homework, because you guys might have slightly different numbers than mine, you can do that. So I'll give you a minute or so to get your homework set up. And then I'm going to start on question 8. So if you want to follow along with me, you can go to question 8 and we'll work on that one. And if you don't want to follow along with me, that's also totally fine. You can just tune me out and get your homework done. All right, so on this one, the thing that makes question 8, in my opinion, a little bit more challenging is the fact that you've got a bunch of fractions in it. So the way that you deal with fractions and inequality is the same way we dealt with fractions when we were doing equations. So if I look at the denominators of all these fractions, I have a 3, a 12, and a 6. And the common denominator between all those numbers would be a 12. So I'm going to multiply both sides of my inequality by a 12. So when I multiply the left-hand side, 12 divided by 3 is 4. 4 times 1 is 4. So I end up with 4 is less than. On this side, 12 divided by 12 is 1, and 1 times -1 is -1. So I'll get a -1. Then 12 divided by 6 is 2. 2 times -5x is -10x. And so by multiplying both sides by the common denominator, I got rid of my fractions, which is very useful because now I can just go ahead and solve this. So to solve that, I'm trying to find out what x is, and I have multiplication by -10 and also a -1 that's being added onto that or subtracted, depending on the way you think about it. And so in order to get x by itself, I need to undo backwards of order of operations. So if I knew what x was, I would multiply by -10 and then add the -1. So to undo that, I'm going to get rid of the -1 and then get rid of the -10. So to get rid of the -1, I'll add 1 to both sides. Oops, 1. And that gives me 5 is less than -10x. And then to get rid of the -10, I'm going to divide by -10. And this is where I need to flip the inequality because I'm dividing both sides by a negative. So since I'm dividing both sides by a negative, I get -1/2 is greater than x. So notice that this sign changed to be a greater than sign. And then they want me to answer this problem in on a number line as well as with interval notation. So I'm going to start with the number line and I'll say, okay, well, x is greater than -1/2. So -1/2 is not a solution itself, but you could get infinitely close to it. Because if I plugged in a -1/2 here, that would be a false statement because -1/2 is not greater than -1/2. But if I did like -2/3 or something like that, which would be like here, that would be a true statement. So it's all of the x's that are on the small side of -1/2, because remember the small side of the arrow is the inequality. So I would graph this like this. And on your homework, the way that you do that is you choose an open circle, put that there, and then you choose the line tool, and then you draw the arrow that goes that way. And if like your homework gets marked wrong, but you're like, I'm pretty sure that graph is right. It might just be that like you put 2 dots here. So like it looks right because you have an open circle there and then a arrow. But like if you have 2 dots there, the computer will interpret it as an incorrect answer because you clicked it twice. So if that happens, just clear it and then redraw it, and that should usually fix the issue. So that would be the number line answer. And then for the interval notation, my lower bound would be -infinity and my upper bound would be -1/2. And I could never plug -infinity into the original expression because -infinity isn't a number. So we'll put a round bracket because -infinity itself is not a solution to the inequality. And then -1/2 is not a solution either because it makes a false statement if you plug it in. So we do a round bracket around that as well. If it had been a less than or equal to sign, then this would have a square bracket. So That's how you do question 8. Yeah.
How would I put or equal to?
Oh, good question. Yeah, very good question. So the way that you type that, so there's 2 ways you can do it. One way is, let me find a question that has it.
One.
1, okay. Okay, maybe my computer didn't have it, but there's like a little yellow arrow, like right here, you can click on. I don't know why it's not showing up in my screenshots. Do you have that? So you can go in there. If you want to type it though, and that's also where you can like find infinity and things like that. But if you want to type it, you would type it like this, and then it will automatically kind of merge it into one symbol. And the way you type infinity, if you don't want to use the little yellow arrow, is 00. I mean, not 00, sorry, 00, like the letter O.
I'm really confused about the part with the -112. because Mine, I was trying. Mine is like the -112. but
Mm-hmm.
It's got, it says 7/6 instead.
Okay, do you want to just tell me what yours is and we can go through it?
1/2 is greater than or equal to -1/2 minus 7/6x.
Like that?
Yeah,
Okay. So what would the common denominator be?
it'd be 6, right?
Yep. So multiply both sides by 6. And that would give 3 is greater than or equal to -3 minus 7x. The reasoning for that is because you distribute the 6 to the -1/2. 6 divided by 2 is 3. 3 times -1 is -3. And then 6 divided by 6 is 1. 1 times -7x is -7x.
Oh, so this is just cancel out.
Uh-huh, yeah, because 6, I mean, so I like to do the division first because it keeps my numbers small. You could also do it though, -7 times 6 is 42, or -42, and then -42 divided by 6 is -7. I just like not having to work with really big numbers, so I'll divide them first and then multiply.
Okay.
But you can do it in whichever order. Any other questions you guys want me to go over that involve fractions? Okay. The next one I thought was kind of challenging was question 12. So if you want to follow along with me for question 12, you can. So on this one, the reason why I think it's challenging is because you have a whole bunch of variables in it. So you have like 3 variables. So to solve this one, you would first of all take care of the parentheses by distributing. So 2 times a is 2a, 2 times -2 is -4, and then 5 times a is 5a, 5 times 4 is 20, and that's greater than or equal to -5a minus 5. And then, so that was just simplifying the left-hand side. And I can actually simplify the left-hand side even further now, because if I have 2 a's plus 5 a's, I could combine those together, which would give me 7 a's. And then -4 plus 20 is going to be +16. So I get +16 is greater than or equal to -5a minus 5. Now I still have multiple variables. I have a -5a on one side and I have a 7a on the other side. So just like with equations, you want to get rid of one of those. So you could choose to subtract 7a, which would cancel this one out. And then on this side, you'd end up with a -12a. I wouldn't personally do it that way because if you have a -12a, eventually you're going to have to divide by -12 and remember to switch your inequality. So if it were me, I would get rid of the -5a. But as long as you remember to switch your inequality, if you divide by a negative, you could get rid of the 7a. So, but I'm going to get rid of the -5a because I think that'll be easier. So I'll add 5a to that side. And to keep my inequality balanced, I'll add it to the other side as well. And that gives 12a plus 16 is greater than or equal to -5. And then to solve for a, I would subtract 16, which gives 12a is greater than or equal to -21. Divide both sides by 12. and I get A is greater than or equal to negative 21 over 12. And that fraction could actually be simplified further because they're both, or like reduced because they're both divisible by 3. So my answer would be A is greater than or equal to negative 7/4. Because 21 over 12 can be reduced to 7 over 4. So this is my answer. However, they asked me to give it in interval notation. And so I personally like thinking about on a number line before I do interval notation. So I might think in my head and say, okay, well, negative 7/4 is a closed circle because it's greater than or equal to. And then A is all of, or the solutions are all of the numbers that are bigger than that. So on a number line, it would look like this. And if I want to put that in interval notation, I would do negative 7/4 as my lower bound, positive infinity as my upper bound. And my negative 7/4 does work if I plug that in. So I'll do a square bracket, but you can't plug infinity into the equation because infinity is not a number. So you do a round bracket around infinity. If this had not had an or equal to sign, then you would do a round bracket around both of them.
So you have, I have number 2, 7 over 3. What if you graph like 7 over 3 on your number line?
Good question. So like on mine, yours is 7 over 3. Yeah, so mine's negative 5/3. So I would think about, well, what is negative 5/3? Like that's an improper fraction that you could also write as negative 1 2/3. Because 3/3 is 1, and then the extra 2/3 would be the fraction part of the mixed number. So on my number line, I would go to negative 1, and then I would go negative 1 1/3, negative 2 1/3. And so for mine, since mine's greater than or equal to, I'd put a closed circle there. And then it's all of the x's that are less than that. So mine would look like that. Yours will look however. Yeah, so 7/3 I think would be like 2 1/3. Yeah. Any other questions you guys have as you've worked through them? Oh, question 13 involves decimals, so maybe I'll go over that one. So if I wanted to solve this one, the first thing I would do is get rid of my parentheses by distributing the 0.8 to both terms. So that would give me 0.04x plus 0.08 times 1,000, I think would be 80. Because 8 times 1,000 would be 8,000, but then you'd move the decimal over twice. I think that's right. And then you'd have minus 0.08x is greater than or equal to 68. So at this point, if you're fine with working with decimals, you can just work with them. So like you could say 0.04 minus 0.08 is negative 0.04x plus 80 is greater than or equal to 68. And then you could like subtract 80 and then divide by that negative number. Or if you don't like working with decimals, you could multiply everything by 100. Because if you multiplied everything by 100, that would essentially make the decimals go away. So like if I multiplied this side by 100 and this side by 100, 100 times 0.04 is just 4, so you'd get 4x, and then you'd get 8,000 and minus 8x greater than or equal to 6,800, like that. And if you think that's an easier way to solve it without the decimals, you can do that to get rid of decimals. Because decimals are essentially like special types of fractions that have denominators of 10 or 100 or 1,000. And so it's kind of like the same strategy as what we did for fractions. So I'll just go ahead and finish solving that one. So 4x minus 8x is negative 4x. 1,000 greater than or equal to 6,800. Then I'd subtract 8,000 from both sides. which would give me negative 4x is greater than or equal to negative 1200, I think. And then this one is one where I need to divide by a negative. So that means I'm going to switch my inequality and go the other direction. And I get x is less than or equal to 300. And so if I were to graph that on a number line, I would have 300 solid circle or solid dot at 300, and then it'd be all of the numbers less than that. So my interval notation for my solution would be negative infinity up to 300, and I would have a square bracket around 300 because you can plug 300 into the inequality and it makes it true. So those were kind of the main ones that I thought were challenging. So with the rest of class time, I'll just leave it open for you guys to ask me any questions you might have. Yeah. Mhm. So if it was less than 300, the thing that would be different is there'd be an open circle on your number line and a round bracket around the 300. Yeah. So infinities always have round brackets because you can't plug infinity into the equation and get a solution. The numbers may have a square bracket or a round bracket depending on whether or not you can plug them in. Because like in this case, I could put a 300 in and it makes it true. And so that's why it's a square bracket. But if it didn't have the or equal to, then it would be a false statement, which is why I do the round bracket. So round brackets are like open circles, essentially. Mhm. Any other questions you guys would like help with? Once you guys finish up the one you're working on, I would recommend maybe going and trying question 14. That's the word problem one. My last class had some questions on that one, but I want you guys to give it a try first before I go over it. Okay, on which problem?
On question one, actually.
Okay, and this one was yours, right?
Yeah, but I had to switch it to one.
Oh, okay. Okay, let me look at what you,
There's no words.
yeah, so if the graph is it, so this is an interval notation. So that is the solution set, but that's not interval notation, because interval notation, you'd say, what's my lower bound? Well, that's -1/2. My upper bound is infinity. And so you'd have
Oh,
like a square bracket, -1/2, comma, infinity, round bracket. Yeah, so it's just the wrong notation. Yeah. Okay, so you subtracted 2 from both sides. And that, well, that that was like your next step of getting rid of the fraction. So that would be a 1. Yeah, that looks good. So then that would be when you multiply by 3, you get 3. Yep, that's right. Oh, so you're saying at this step, your step.
Yeah.
Okay, sorry.
It's like.
Yeah, so we
That's
have an X on both sides, which means that you want to get rid of one of them. So I would probably get rid of the -1 And it actually doesn't cancel out both sides, because if you do, like if you add an x to this side and you add an x to this side, this will cancel out, but you get a 2 here, a 2x. So you'll have 3 is less than 2x, and then you just divide by 2.
Okay.
Yeah. So if it's negative infinity to positive infinity, your number line actually should go that way.
Oh.
And that's because, I'm assuming you just solved it by dividing by -5. But when you divide by a negative, you flip the sign. Yep, you got it. Any other questions? Just squeeze past you. Okay.
So,
Okay, yeah, so you solved it probably by multiplying by 3, so we got x's. Yeah, so you didn't multiply by a -3, which means you don't have to flip the sign. It's
Okay.
only if you multiply by a negative.
Alright.
So this part is right, because what this is saying is that 6 is your lower bound, and then you go positive infinity. Yeah, so that will fix it. Mhm. Any other questions?
This part of the question, am I taking this equation and this equation and create an inequality between them?
Yeah, so what we're looking for is how many years will it take for the government major to earn at least the same amount as the math major? So-
it'd be like that pay less than or equal to the other pay.
Yeah, so, so which one was it? At
So that's
least?
the government pay. So yes, it's
So we
always.
want government and math, and we want government to be at least, so that means greater than or equal to, so it's gonna be like
Also,
that.
government's gonna be. greater than.
Yeah, because you want the government to be at least the same amount, so it's okay if it's more than, but you want it to be at least that much. Mhm.
So make sure I understood that correctly.
Mhm.
Do you just make it the same equation as the first one?
No, because it's asking a different question. So this one was, how many years would it take for the math major to be earning at least 90,000? This one is saying, how many years will it take the government major to earn at least the same amount as the math major? And so what we're doing here is we want the government major. This is kind of the general structure of how that equation or inequality will go, because you want the government pay to be greater than or equal to the math pay. And then you like plug in your amounts of like how much the government one gets paid and how much the math does. So like this is the formula for government pay. This is the formula for math pay. Yeah, I mean technically you could say math is less than or equal to government. So like, yeah, it doesn't matter. But the important part is that the government is on the big side of the arrow and the math is on the little side of the arrow, because you want the government to be bigger than the math pay.
Thank you.
Uh-huh. Mhm. Yes. Yeah. It's a square bracket. Yeah, so if it's an open circle, it's actually a round bracket. So you do a round parenthesis around that as well. If it was a closed circle, then you do a square bracket, but you did a curly bracket. So there's like 3 different kinds of brackets here. Yeah. And like what that means is that x is less than 3, but not less than or equal to. So like if you were writing in an inequality for it, it'd be x is less than 3. But if it was a closed circle, then the x is less than or equal to 3, and that's when you'd have a square bracket. And the square brackets are shift that button.
Another question.
Yeah.
Right, here. This is my number 8.
Mm-hmm.
This is my number 8.
Mm-hmm.
And then when I did it, right?
So you multiply by 4, that gave you that. Yeah. Yep, that was good.
That was good, right?
Mhm.
So now, remind me.
Yep. And you flipped it when you divided by 7. So, yep.
Yes, so,
Oh, this should be a negative though, because you divide by -7 and 4 divided by a negative.
right there.
Yeah, because at this step, when you do -7 divided by -7, that's just a +1, but 4 divided by -7 is -4/7. Yeah.
Another question for
Mhm.
you. This is greater than or less than?
So the way you would read that is you would say 4 is greater than or equal to -7x.
So
You could also say though, -7x is less than or equal to 4. So like if you read it from left to right, we'd say it's greater than. All right, it's 2:50, so we'll wrap up class and I'll see you guys tomorrow. Hope you guys have a good day.